Welcome to the onvif certification program. The topic of this video is onvif, PoE, and iscsi protocols. This training shall enable you to get to know the basics of onvif, PoE, and iscsi protocols. Understand the application of each onvif profile and know how PoE powering system and iscsi work, as well as understand the benefits onvif, PoE, and iscsi protocols provide. Let's get started. In the first part, we will introduce the basic concept of onvif and talk about all the onvif profiles as well as the benefits that onvif provides to different target groups. Then we'll move on to PoE. The basics of PoE and its powering system, powering modes, and powering standards will be explained. In the last part, we'll have a look at iscsi. We'll explain its definition, work principle, and the benefits that it supports. Now let's start with onvif first. onvif, which stands for Open Network Video Interface Forum, is an organization started in 2008 by Axis Communications, Bosch Security Systems, and Sony. It is a global and open industry forum with the goal of facilitating the development and use of a global open standard for the interface of physical IP-based security products. Its mission is to provide and promote open interfaces to security products for effective interoperability and enable all security systems to share one interface. onvif creates a standard for how IP products within video surveillance and other physical security areas can communicate with each other. It breaks the barriers between different brands and makes interoperability open to all companies and organizations. onvif also works with global standards groups such as IEC, International Electrotechnical Commission, and ISO to have them adopt onvif specifications. The work in onvif is driven and carried out by its members in various committees and working groups. The organization structure is as follows. On the top is the steering committee, which is responsible for strategy and budgeting for onvif. The technical committee drives the development of onvif core specifications as well as the technical direction and roadmap. It also oversees the video enhancement work group. Then the Technical Services Committee is responsible for the development of profiles, test specification, test tool, and conformance process. Working groups under the TSC include the TLS add-on work group and the testing work group. The Communication Committee is responsible for the organization's external and internal communication. These committees and work groups work together to provide onvif members benefits. onvif membership is open to manufacturers, software developers, consultants, system integrators, end users, and other interest groups that wish to participate in onvif activities. onvif offers 5 classes of annual memberships to accommodate different levels of participation: full, contributing, registered affiliate, user, and observer. Full and contributing members can actively influence the development of the standard by participating in the work of the organization. Registered affiliates are affiliates of full and contributing members and share many of the same privileges of their parent company's membership. The user member level is open to organizations who wish to use the network interface specification and have access to specification proposals but do not want to participate in any work of the organization. The observer member level is open to organizations who do not want to participate in any work within the onvif organization, but who are granted certain limited benefits such as the right to access network interface specification test tools. onvif has a robust and growing member base on 6 continents. The onvif membership is comprised of leading companies in the global IP-based physical security products market, including front-runners in camera, video management system, and access control development. So far, onvif has 468 members, including 23 full member companies. Today, the organization's member base collectively offers thousands of onvif conformant products in all parts of the world. The key focus of onvif is true interoperability and provides membership benefits for manufacturers as well as end users, integrators, and specifiers. onvif gives end users the flexibility to pick and choose optimal products for their needs without being locked into a specific brand. An onvif conformant video management software, for instance, will allow end users to integrate onvif conformant devices from different hardware manufacturers. Having onvif conformant products is like having an insurance policy that future-proofs their system for a more secure investment. onvif conformant products allow integrators to create a flexible, cost-effective, and future-proof system. onvif enables them to choose optimal products from different vendors. The conformant products allow integrators to be confident in their interoperability and make integration of products from different vendors easier. onvif membership makes manufacturers' products onvif conformant and helps their products gain market acceptance and gives them access to projects, thereby helping them increase sales. As an onvif member, you can build partnerships by being part of the growing IP interoperability community, as onvif is already supported by the majority of the largest network video companies. In order for your product to be onvif conformant, you must be an onvif member and the product must support at least one onvif profile. Conformance to profiles is the only way that ensures compatibility between onvif conformant products. Therefore, only registered products with conformance to a profile are considered to be onvif conformant. So next, let's have a look at the onvif profile concept. An onvif profile has a fixed and comprehensive set of features that enable a functional product to be developed solely on the profile specification. onvif profiles make it easy to recognize how onvif conformant devices and clients are compatible with one another. An onvif profile has a fixed set of features that must be supported by a conformant device and client. It allows users to easily identify specific interoperability features between client and device. The network interface specifications are packaged into onvif profiles or add-ons. So there is no need for extensive technical knowledge of specific versions. To test the conformance of products to a profile, there are the onvif device test tool and client test tool. onvif profiles make interoperability between products of different brands easier and more effective. There are 7 types of onvif profiles and each has its own supported specifications and features. A profile has mandatory as well as conditional features, which are features that should be implemented by an onvif conformant device or client if it supports that feature in any way, including any proprietary way. Specifications for profiles cannot be changed to ensure backward compatibility. Clients and devices can support more than one onvif profile. For instance, a network camera with local storage can conform to both profile S and G. Generally speaking, access control systems can make use of profile A, C, D, and M. Video systems can make use of D, G, M, S, and T. Actually, access control systems can be integrated with a video surveillance system using onvif profile S. Now let's check out these profiles one by one. Profile C is for products used in an electronic access control system. Profile C conformant devices and clients support site information, door access control, and event and alarm management. Profile A is for products used in an electronic access control system. A Profile A conformant device can retrieve information, status and events, and configure entities such as access rules, credentials, and schedules. A Profile A conformant client can provide configurations of access rules, credentials, and schedules. The client can also retrieve and receive standardized access control related events. onvif Profile D complements Profile A and Profile C in enabling standardized communications in an IP-based electronic access control system. It specifies the interfaces for peripheral input devices such as token readers, biometric readers, cameras, keypads, sensors, and output devices such as locks, displays, and LEDs. Profile M essentially aims to standardize interfaces that specify how devices or clients should send or retrieve and interpret analytics metadata, as well as handle events. A Profile M conformant device can be an IP camera or a service with analytics capabilities that can use Profile M interfaces to send metadata over an IP network to a client. A Profile M conformant client can be a video management software (VMS) program, a network video recorder (NVR), or a server or cloud-based service that can make use of Profile M interfaces to configure, request, and control the streaming of metadata over an IP network from a Profile M device or service. Profile S is designed for IP-based video systems. A Profile S device, example an IP network camera or video encoder, is one that can send video data over an IP network to a Profile S client. A Profile S client, example, a video management software, is one that can configure, request, and control video streaming over an IP network from a Profile S device. Profile S also covers onvif specifications for PTZ control, audio in, multicasting, and relay outputs for conformant devices and clients that support such features. Profile G is designed for IP-based video systems. A Profile G device, example an IP network camera or video encoder, is one that can record video data over an IP network or on the device itself. A Profile G client, example a video management software, is one that can configure, request, and control recording of video data over an IP network from a Profile G conformant device. Profile G also includes support for receiving audio and metadata stream if the client supports those features. Profile T is designed for IP-based video systems. Profile T supports video streaming features such as the use of H.265 encoding formats, imaging settings, and alarm events such as motion and tampering detection. Mandatory features for devices also include on-screen display and metadata streaming, while mandatory features for clients also include PTZ control. Profile T also covers onvif specifications for HTTPS streaming, PTZ configuration, motion region configuration, digital inputs and relay outputs, and bidirectional audio for conformant devices and clients that support such features. Now let's move on to the second part, PoE. PoE, or Power over Ethernet, describes any of several standards or ad hoc systems that pass electric power along with data on twisted pair Ethernet cabling. This allows a single cable to provide both a data connection and enough electricity to power devices such as wireless access points, Internet Protocol cameras, and Voice over Internet Protocol phones. By using one cable to transfer both data and power, PoE makes device installation easy and saves costs. And it's more secure as it can avoid issues caused by power cables. The network connection between devices is also more stable. So how does PoE power supply system work? Actually, a complete PoE power supply system consists of a power source, PS, power sourcing equipment, PSE, power interface, PI, and power device, PD. PS provides power for the whole PoE system. PSE is the equipment that directly supplies power to PD. PSE is divided into two types: internal, endpoint, and external, midspan. Internal refers to the integration of PSE in the switch or NVR, and external refers to the independence of PSE and switch or NVR. The main functions supported by PSE include finding and detecting PD, classifying and supplying power to PD, power management, real-time monitoring, and detecting whether the connection with PD is disconnected. PI refers to the network port that supports PoE function. It's also called PoE port. The device-like IP camera in the picture is PD. While receiving the PoE power supply, the PD device can be connected to other power sources for power redundancy backup. So the whole system works in this way: the PSE powers up the PD, and data is transmitted between them via the same twisted pair cable. Well, there are multiple PoE power transmitting modes. We'll introduce them one by one. There are 3 power supplying modes: Alternative A, Alternative B, and 4-pair PoE. For 10 base T and 100 base TX, only 2 of the 4 signal pairs in a typical Cat5 cable are used, that is, pins 1, 2, 3, and 6 are used for data, and others are spare. Alternative A powers over data pairs. Alternative B separates the data and the power conductors, making troubleshooting easier. It also makes full use of all 4 twisted pairs in a typical Cat5 cable. The positive voltage is applied to pins 4 and 5, and the negative to pins 7 and 8. PSE does not allow the above powering modes to be used at the same time, and can only adopt one mode, but PD must be able to adapt to these 2 modes at the same time. Alternative A transports power on the same wires as data for 10 and 100 megabit per second Ethernet variants. For gigabit Ethernet and faster, both alternatives A and B transport power on wire pairs are also used for data, since all 4 pairs are used for data transmission at these speeds. 4-pair PoE provides power using all 4 pairs of a twisted pair cable. This enables higher power for applications like pan, tilt, zoom cameras, high-performance WAPs. For 2 and 4-pair Ethernet, there are 4 types of standardized PoE standards: AF, AT, and 2BTs. Each of them has different parameters. The original AF PoE standard was introduced in 2003. It provides up to 15.4 watts of DC power with a minimum of 44 volts DC and 350 milliamperes on each port. Only 12.95 watts is assumed to be available at the powered device, as some power dissipates in the cable. In 2009, the updated AT PoE standard was released, which is also known as PoE Plus or PoE Plus, providing up to 25.5 W of power for Type 2 devices. The AT standard prohibits a powered device from using all 4 pairs for power. The BT standard was released in 2018. It further expands the power capabilities of 802.3 AT. It is also known as PoE++ or 4-pair PoE. The standard introduces 2 additional power types, up to 51 watts delivered power, Type 3, and up to 71.3 watts delivered power, Type 4. Each pair of twisted pairs needs to handle a current of up to 600 milliamperes, Type 3, or 960 milliamperes, Type 4. Additionally, support for 2.5 gigabit base T, 5 gigabit base T, and 10 gigabit base T is included. This development opens the door to new applications and expands the use of applications such as high-performance wireless access points and surveillance cameras. Now let's move on to the last topic, iscsi. iscsi stands for the Internet Small Computer System Interface Protocol. It is a storage area networking protocol used to send block storage between storage and server client that isn't directly connected to it. It runs over Ethernet networks and was originally viewed as a less expensive alternative to fiber channel. It is a very mature and popular SAN technology. So how iscsi works in SAN? An iscsi storage area network consists of iscsi initiators on storage clients and iscsi targets on storage array controllers. As the initiator and the target are connected to network. So when an initiator is going to establish a connection with a target, it has to discover it by IP address first, then log into the target. The initiator sends SCSI command, which is encapsulated in iscsi. Then through TCP and IP over the internet to the target. In short, iscsi provides block-level access to storage devices by carrying SCSI commands over a TCP and IP network. So what benefits we can get from iscsi? First, due to the transmission through Ethernet, enterprises can use existing Ethernet facilities to deploy iscsi storage network without changing the enterprise network system, so its deployment cost is relatively low. Second, iscsi is encapsulated in IP packets for transmission, so it has all the advantages of TCP and IP, such as reliable transmission. Third, the protocol itself has no distance limitation. Because it uses TCP and IP for transmission, it can be deployed in the LAN in different scenarios, which greatly expands the deployment range of its storage network. 4. The structure of iscsi is simple and is easy to understand. An iscsi protocol is common, so even devices from multiple manufacturers can work and be used together, which greatly protects the investment of enterprises. Last, since the iscsi storage system can be directly established in the existing network system without changing the network system, enterprise users who need to increase storage space only need to increase the storage device. Therefore, iscsi storage has high expandability. After this course, you must know the basics of onvif, PoE, and iscsi protocols, understand the application of each onvif profile, and know how PoE powering system and iscsi work, as well as understand the benefits onvif, PoE, and iscsi protocols provide. That's all for the onvif and PoE and iscsi protocols introduction. Thanks for watching. See you next time.